Assalamualaikum. This present is on project management of Burj Khalifa Smart Project. We are from AP2256D. This presentation is to present to Sir Muhammad Saiful Alizan Nordin. This is our team members. Muhammad Firdaus bin Zaharin, me, Muhammad Amar bin Zainuddin, Nurul Syafiqah binti Mazlan, Nur Izian Zayana binti Zulkifli, and lastly Raihana binti Abdul Karim.
SMART is defined as an acronym used in project management to define certain objectives, which is, when applied to the goals of project, allow the project to run more smoothly and lead to successful project closure. However, in almost every case, a SMART project manager can rely on the application of SMART objectives during both project planning and execution in order to relieve such pressures. So we move to specific goals. A specific goal is one that is well defined, where any work item should be clear to everyone who will be delivering any part of the work and to the project stakeholders. Tasks or work items should be as concise as possible, whilst conveying all the information that is necessary to deliver on the stated goal. In some cases, a team may not have all the specific information that is required prior to starting work on a goal. In such a case, any remaining ambiguity should be removed in a systematic manner as the work progresses. Next is measurable goals. Measurable goals are quantifiable, meaning this is a way to assess and determine the progress being made as the work is being delivered. Defining the measurement that will be applied to delivery of the project goals can also help to remove ambiguity during the planning process. And the most important is, measurable goals provide a definitive way to state the particular goal that has been completely delivered and does not require additional effort. Next, we move to the third one, which is an agreed upon goal. An agreed upon goal is one that has buy-in not only from the team, but also from the stakeholders or sponsors of a project. The most important details that might otherwise remain hidden may be uncovered by obtaining formal agreement before starting work on any specific delivery item in the project plan. Agreed upon goals should be formally captured and signed off on by all participants who have a say in approving the project deliveries. Obtaining this buy-in ahead of time helps to prevent disagreements that can arise over ongoing project payments and allows for successful closure of the project in a timely manner. Next, we move to the fourth one, which is realistic goals. It seems to go without saying that the goals of a project should be realistic. However, many goals that appear to be valid may not be truly realistic when compared to the overall constraints of the project. It is important that the goals of any project are realistic in terms of the well-known triple constraint of project management, consisting of scope, schedule, and resource. Other than that, any uncertainty in the delivery plan might indicate certain goals are, in fact, unrealistic within the original constraints of the project. The last one is time-related goals. A SMART goal will always be time-related because goals often cannot be achieved without a deadline. A deadline serves as a great motivator and can provide context to recognize the various tasks necessary to reach that goal in the time allotted. Therefore, giving the goal time constraints helps keep the management on track. Have in mind when planning that the project could be protracted in order to gain approval. There's a challenge for the project managers as they should schedule payments to vendors and suppliers. Additional measurement and designing of better layout also could prolong the process compared to the length of the conventional building process.
Assalamualaikum, my name is Shafika binti Mazlan, and today I would like to present about our case study, which is the Burj Khalifa Dubai, and I would like to present about the description of the project, type of project, size, nature, and its smart goal. The Burj Khalifa is the world's tallest skyscraper and one of the world's most visited tourist attractions. Burj Khalifa is a multi-use development skyscraper with more than 160, including a hotel, observation deck, restaurant, fitness and recreation club, and 37 levels of corporate office. It was created by a Dubai government with the purpose of making the city a financial, commercial and tourist hub. The Burj Khalifa skyscraper, which cost more than 1.5 billion to build, stand at 8 to 8 meter above ground level, making it the world's tallest structure and the largest installations of an aluminium and glass facade. The project was supposed to show piece of the gigantic Burj Khalifa development, which will reach an unparalleled height in the sky, and it lasts 6 years from 2004 to 2009. Now we will look at the type of the project. The Burj Khalifa skyscraper, formerly known as the Burj Dubai, is the world's tallest man-made structure and it located in the heart of Dubai, which rose to a record height of 828 meters. The Burj Khalifa design incorporates local cultural influence with cutting-edge technology to ensure outstanding performance in a harsh desert climate. The Y-shaped floor plans view of the Arabian Gulf are maximized to reduce wind force while enhancing constructability at the same time. Each one is supported by hexagon hubs, a 6-side central core with its own high-performance concrete core and surrounding column. The design-tight geometry ensures that all the shell center core and column parts are aligned. The seatbelts are designed to follow the lower grip, and stepping is accomplished by linking column above with wall below to produce a small float road. As a result, construction could continue without the normal delay caused by the column move. Next is the size. The building was originally known as the Burj Dubai before being renamed the Burj Khalifa in 2010. It is a skyscraper in Dubai, United Arab Emirates, with a total height of 828 meters, and the size area is 104,210 meters, and the number of stories is 162. The building gross area is 454,249 square meters. We will look at the nature. The Burj Khalifa, in addition to its world record-breaking height, incorporates integrative mechanical, electrical, and plumbing (MEP) solutions that make the skyscraper highly efficient while reducing environmental impact and waste. The main goal was to provide comfort and healthy interior environment. The team designed a lifeboat vertical transit system with improved monitoring and control to allow for a quiet ingress in the case of an emergency. The office pavilion has a backup system that can perform crucial duties including water supplies and drainage in the event of the power loss. Thus, the Burj Khalifa was intended to combat the wind, which become increasingly important as altitude increase. The construction is made up of several stalks that form an uneven pattern around the center spire as they climb to the sky. This unique design deflects wind around the tower, preventing structure whirlpool of the air currents, all vortices from swaying the structure from side to side, potentially destroying it. The last one, we will look at the smart goal. The most advanced technology in wind engineering, structure system, building material and process were employed to construct a skyscraper. The material were tested in wind tunnel at hurricane speed 200 km per hour to guarantee that they can withstand any conditions. The world's tallest building, Burj Khalifa, used a variety of link building and Internet of Things (IoT) technology to improve air quality, thermal comfort, and light level for its residents. The Burj Khalifa team collaborate with Honeywell Building Solutions to put Honeywell Outcome-Based Service (OBS) technology to the test across the mechanical component of the HVAC system. The OBS software as a service solution capture a real-time field data, transfer it to the Honeywell Sensient IoT platform, detect, analyze, and run smart algorithms to predict and preemptively manage the building mechanical system. At the center of OBS is Honeywell Sensient, a cloud-based IoT platform that provides safe big data capabilities for all Honeywell connected solutions. The technology allows facilities managers at the Burj Khalifa to use building data analysis for predictive and predictive maintenance. The Burj Khalifa also uses Honeywell EBI technology, which provides a single view of building technology system and improve the connectivity of smart devices to improve efficiency, performance, and operational control. Thanks to the real-time facilities data, Burj Khalifa facilities management personnel can now spot occurrence faster, respond more quickly, and lessen any damage more cost-effectively.
Assalamualaikum to Saiful. My name is Nur Izyan Zainah binti Zulkifli. So I will explain about the organizational structure of the project management team and their roles of expertise. As we can see, this is the organizational chart of the project management team of Burj Khalifa. It consists of several expertise that lead by the owner, master planner, followed by project manager and other professionals such as architect, consultant, engineer, quantity surveyor, and lastly, contractors. Next, I will also explain about the roles of each expertise in the organizational chart. Firstly is the owner. The owner of this project is Emaar Properties. The owner needs to provide funding for the project and must make sure the financial source for the project is adequate so that the project will be completed in time. The next role of the owner is to make a decision for the project, because a good decision making at the level of the top management is the key to the project success. The owner also responsible for selecting the employee who will involve in the project, such as architect, engineers, and contractors. Next is the master planner. They are in charge to suggest budget allocation of the construction project in order to avoid any issues regarding the financial, and the budget will still be in control. They also need to provide team members, clients, and stakeholders with the progress reports and forecasts to ensure the project are on schedule. The next one is engaging with surveyors, engineers, and architects is one of the master planner's roles. Besides, project manager is another major role in the construction project. They will represent the client or the owner and be in charge of the day-to-day project management. Christopher Harris from Turner International LLC was appointed as a project manager for Burj Khalifa. Basically, the role of project manager is oversees in every aspect of the project, from planning, execution, monitoring, and controlling of construction project activities. They are responsible to determine objective, schedule, and resource budget for the project. They also involve in risk management, value management exercises. The next one is architect. Architect can be defined as a skilled professional who designs and plans the building. Emaar Properties hire a global architect, urban planning, and engineering firm, which is Skidmore, Owens and Merrill, to be a designer for this project, and Adrian Smith was the chief architect. One of the main roles of architect is to design or draw a plan of the building before the construction begins. They are responsible to prepare a concept and a detailed design in accordance with the client requirements and specifications. During the construction stage, an architect should be visiting the construction site periodically for the inspections. This is because it is necessary to ensure that the work is proceeding generally. Next, they need to prepare blueprint, specifications, and construction documents such as contract drawings, contract forms, technical specification, and design instructions. Next is consultant. Consultants need to provide advice on setting up the project. They are also responsible for any problems or conflicts and guiding in amendments to contractors' contract and tender documentation. After that, let's look at the roles of civil and structural engineer. Bill Baker was appointed as the engineer for Burj Khalifa along with CBN engineers and Heidel Consulting in order to assist in the overall design of the project. Their roles are to monitor and ensuring that the performance of structural design, prepare key essential plans, study different equation, strategies, and application to make a certain appropriate procedure and applications, and also carry out the calculation of strength, loads, and force. Then the roles of mechanical and electrical engineer. They are responsible for planning, designing, and developing policy standards. They are also in charge of monitoring and implementing all mechanical related operations at the site. After that, the mechanical site engineers need to supervise all installations of machines and equipment in order to ensure that it complies with their designs, methods, and specifications. As a continuation, the roles of quantity surveyor is to prepare a detailed cost plan in every aspect of the project. Another core function of quantity surveyors in any construction project is to value the completed works and arrange for payments. They are also responsible to advise on matters regarding legal and contractual issues or administration project. Before I highlight the last point, let's look at the roles of main contractor. The roles and duties that need to be carried out by the main contractor such as to coordinate all construction project tasks. It includes in managing the personnel on site and planning how the construction will be carried out during the start of the project until at the end in accordance with all laws, rules, and regulations. The main contractor will be tasked to monitor and evaluate the construction project in order to achieve the mission and vision of the project as the requirement by the owner. The main contractor also responsible to hire a specialist subcontractor. They have the capability in selecting the best and skilled subcontractors for the project or workers. They are more knowledgeable about the labor force employed in the construction industry. Last but not least is subcontractor. The subcontractor has been hired by the main contractor or the project manager to carry out a specific aspect of the project. Their roles are to carry out duties as per request on behalf of the general contractor, estimate cost of own work, comply with contractual requirements and safety plans and rules, and lastly manage the work without or with minimal supervision.
Assalamualaikum warahmatullahi wabarakatuh. My name is Raihana binti Abdul Karim and today I would like to present about the summary of the project management practice using the disruptive technology during all the phases. The project management practice consists of 5 phases, which is initial, planning, execution, controlling, and closing. First of all, initiation phase. The development of Burj Khalifa has been decided by the Sheikh Mohammed, the President of Dubai, to construct the structure of the project, and it was designed to accommodate the range of commercial, residential, and hospitality business. The project was located at the Sheikh Mohammed bin Rashid Boulevard, Dubai, United Arab Emirates, was spending high-level budget at $876 million, estimating in 57 months, starting 2004 until 2008. And it was complete in the final phase at 2009. According to the Skyscraper Center, the stakeholders have been authorized to appoint the best professional to carry this big project to avoid any risk and problem arising. So the project organization of Burj Khalifa, that consists of developer, Emaar Properties, design architect, engineer from Skidmore, Owing and Merrill LLP, project manager from Turner International LLC, consultant engineer from Haider Consulting and general contractor from Samsung Engineering Korea, Basic Belgium, and Arab Tech Dubai based contractor. Before carrying out the construction work, the appointed professional concerned about the design, so they've been decided to adopt the wind engineering. Wind forces and consequent motion in the top floor of the Burj Khalifa become important consideration in structural design. This odd shape deflect the winds around the structure, preventing structural whirlpool of air current. Wind tunnel research and testing procedure were created from the start of the project to gain a complete understanding of the building wind behavior and reaction. Second phase is the planning phase. In this phase, time to hand over the project to the developer, which is Emaar Properties, to carry on the duties as planned. The scope of the project was very high after the problem occurred in the cost, which is exceed the actual planning budget in the initial phase, which is $876 million to $1.5 billion. It is to make the Burj Khalifa as a Dubai's benchmark and be known to the world. It is necessary to bring the proper process onward to attain the several goals that have been planned in the initial phase. Besides that, the geotechnical technology being used in this phase to investigate and test the condition of the soil within 6 months of the time frame, and foundation construction another 1 year and a half. The deep foundation was designated, which is 3.7 meters thick and 192 board plies, have challenged the labor and professional due to the weak soil, and the size of the structure may cause heavy load on the foundation. The aims of this design is to align with the stakeholders' objective, that also to balance the building weight across the larger volume of soil and reducing the load in any particular area. In the budget detail, the range of the labor cost could be 500 until 1,500 Arab Emirates dirham per month, contributed to the budget proposed by the stakeholders. However, the detailed budget does not align as a plan. The budget was exceeded above $876 million, which are approximately $1.5 billion, due to the worldwide economic downturn in 2008, resulted in a considerable increase in raw material costs. For example, iron price have increased by 75% in a year. For the communication planning, Emaar Property used over 65 different consultants and over 12,000 expert and skilled employees on this project. Hence, great communication and frequent reporting were necessary to ensure well progress and successful budget and expectation management. The issue of the communication system became apparent after the building reached 30 stories. The walkie-talkie got less and less dependable as the tower grew, causing the delay and safety concern. However, Samsung found the solution to bring the wireless mesh network to have a clear voice during communicating with the others labor, and no resistance to real-time video stream and surveillance. This wireless mesh solved a crucial communication issues, allowing construction to proceed securely and on schedule. Next is risk analysis. The goal of risk analysis is to reduce the chance of the unfavorable project consequences, and the first step is to determine the cost of the impact. In skyscrapers, a new vital component is taken into account. The evacuation poses several difficulties and need to have a proper system of excavation with refuge space that can withstand fire and heat for up to 2 hours. Air pumps are also available in these rooms. Apart from that, several risks of the Burj Khalifa development project has been identified in the design stage and construction stage. For the schedule detail, the project activity has been done as planned in the schedule. The Gantt chart technique was reported they built 10 floors a month, causing take too much time until 2,192 days to complete the project. Various issues arise during the development work, causing the project done 9 months later in September 2009. Furthermore, the planning procurement is the next major component for turning the vision into reality was close and early involvement with government authorities, utilities corporation, and other key stakeholders. The company listed in the slide collaborated and worked closely with the Emaar Properties to supply necessary materials and service for the Burj Khalifa project. Next phase is the execution phase. The quality management was adopted in the execution phase for the purpose to maintain quality in all aspects of the project development. It is performing the quality activity to meet the requirement by using any resources. To achieve quality goal, Burj Khalifa management employed a project quality plan, inspection test plan, and checklist. Daily operations were built using a project management information system, which allow for real-time changes and information access from anywhere. For contract administration, the contract signed between Armani Hotel and Emaar Properties slightly changed the initial design of the building. The goal of Emaar Property collaborate with the Armani Hotel to establish a luxurious space in the Burj Khalifa with the high-quality facilities provided. Stakeholders management. Stakeholders known as an individual who has interest in something, especially in business. Basically, the development of Burj Khalifa had involved at least 156 stakeholders, include 78 companies, 16 consultants, 14 contractors, 3 financial institutions, 2 owners, 2 real estate companies, 3 subcontractors, and 38 suppliers. External wall technology. It is being used in this phase to maintain the quality of the building and to avoid from instant heat temperature. Moreover, to prevent from any risk factor that may danger the client. For the Burj Khalifa, special 2-pane windows were installed. The exterior face reflects daily solar heat and is protected from ultraviolet rays by a thin coating of metal. Infrared radiation renders the first pane ineffective once more. To keep infrared rays out, the inner pane is coated with a tiny coating of silver. After that, monitoring and controlling phase. In this phase, the first item is the quality control. The project quality control method are created in accordance with the project specification before the project deliverable, and it was designed and formally presented to the consultant for approval, after which they are distributed to all elements of the project. Therefore, there was a list of 3 phases quality control program of Burj Khalifa development. Firstly, engineering phase. The 280,000 square meter of Burj Khalifa consists of the building houses a Giorgio Armani hotel as well as office, residential, and retail space. The tower is made up of 3 parts that are grouped around central buttress core and are made of reinforced concrete and glass. To decrease wind pressure and improve constructability, SOM devised to adopt wall and floor technology, which is a basic Y-shaped layout. Besides that, administration and implementation. Implementing the building's tool and procedure necessitated the ability to move massive amount of steel and concrete higher into the air as the structure got taller. Dealing with the weather fluctuation might make the construction process more difficult. Next is performance measurement and measuring phase. Effort from representative sample of the workforce. If there any occurrence or accident, they must be investigated and remedial action performed. Violators should be investigated and disciplinary action imposed. All project departments should incorporate performance, measurement, and evaluation. For the cost control, the development of Burj Khalifa has so many issues regarding the budget and cost estimating. The lack of detail accessible in regard to cost budgeting and control causing difficult to make an analysis of Burj Khalifa because this cost did not reduce the company expenses. It might be assumed that Burj Khalifa handling of them was inadequate. As previously stated, the Burj Khalifa was anticipated to cost $876 million. but the final cost estimated to be $1.5 billion. For the schedule control, the Burj Khalifa faced time constraint throughout the 5 years building process. The height of the Burj Khalifa, for example, poses a building challenge. As the tower grew, concrete had to be adjusted to accommodate the weight and pressure of the structure, resulting in error. Because it was not anticipated, this lengthened the building process. Furthermore, because the temperature approached 50 degrees Celsius, causing the concrete to fracture. Concrete-related work was done at night, lengthening the entire construction duration. This phase, wall and floor technology being used. SOM decided to apply the wall and floor technology in the development of Burj Khalifa to reduce wind pressure and improve constructability. This technology was described as a Y-shaped layout with each wing is buttressed by a six-sided central core or hexagonal hub, which has its own high-performance concrete core and perimeter columns. The geometric design was aligning with the part of the wall and floor technology and made the incredible tower of the world. The last phase is the closure phase. The Burj Khalifa was completed in January 2010. 10,000 fireworks were let off during the launch ceremony of Burj Khalifa. The light beam projected on and surrounding the tower, as well as other music, light and water effects. Hundreds of media organizations from all around the world broadcast live from the site. In addition to the media, nearly 6,000 people were out to witness the start of this historic event. However, the lesson learned from the development of the Burj Khalifa, members of the project organization will have gained a better understanding of how to carry out this sort of project in the future, as well as an estimate of how long the different activities on this type of project will take to complete. The primary technology used at the Burj Khalifa building after the completion of the project is a fire safety technology that consists of fire alarm, sprinkler system, stable pressurization, and smoke evacuation system. There are additionally 38 fire and smoke-resistant evacuation lifts on the Burj Khalifa.
Next, we move to the challenge faced within the project management cycle. The challenge is divided by two categories, which is structure and constructions. Under structure, there's an undesigned structure, which is the challenge faced by the workers where they had to complete this building structure on time. The time given for its completion is about 6 years, but the engineers need 3 years to design the building structure, and if it happens then within the next 3 years, the building's construction will become impossible for its completion. Therefore, the engineering team decided to start work and develop the building's design side by side. The next one is buttress core structure. For Burj Khalifa construction, the management team called Emaar handed over this project to the USA's top construction company, where it is located in Chicago. The company had already designed many other structures of various buildings very well, but this time they get indulged in some hardships. Their challenge is to make such a building that can stand within tons concrete and steel, which has about 160 floors in it, and natural light get past between. After the efforts of day and night, the firm finally found a solution in case of introducing buttress structure, which is, according to William Baker, the spiraling Y-shaped plan was also utilized to shape the structural concrete Burj Dubai to reduce the wind forces on the tower, as well as to keep the structure simple and foster constructability. So we move next categories, which is construction, which is present soil is not appropriate for a skyscraper. When the time came to place the building space, there was a problem arises that for situating that the most tallest building where the engineers need solid huge rocks placing below. Therefore, the structure of the building is stood on any heavy hard concrete, whereas the construction Thompson area was having acute weak cracks, and the soil present below is not appropriate to withstand a skyscraper building. Thereby, to overcome this challenge, engineers applied simple formula of friction, which is they decided to stand the building structure on a 192 equally distributed solid steel piles dug 50 meters underground to maintain the building's weight and base. Next one is concrete section system. Till now, they had made many floors, but then instantly they had to face another problems, and that is when the workers had to take the concrete mixture to the upper floors for construction purpose. The concrete gets dried due to summer heat. Then the team decided to display concrete suction system, which is for this purpose they installed 3 thick powerful pipes from bottom to top, which is can place concrete mixture at any floor through having the weight more than of 1 leg elephants. Through the system, the concrete mixture remains in liquid form and can easily be pumped. But it has been done at night time by the workers when the tendency of heat was lesser. Next is ball crane operators. Here the team had to face a new challenge, and that is the cranes used at the construction site will have the capacity to uplift the material to the 120th floor. Not only this, the crane operators who operate these machines will refuse to work above this height. To minimize this height, the HR department hired a bulk crane operators from all over the world. These crane operators have one thing in common, and that is they were not afraid of working at the height. These crane operators work at a height of about 700 meters, which is have to spend about almost 12 hours working per day. The next one is installation of glass panels. Here the need comes to place about 24,000 glass panels on it. When it comes in this kind of situation, these glass panels become unable to protect the inner side of the building from entering the sun rays from outside. So at this stage, the measuring temperature inside was about 100 degrees centigrade. So to keep the buildings inside temperature cool, the firm need to install many strong cooling applications that utilize 10% more electricity cost overall. To find out of the solution, 18 months have been passed. Alas, one day the great renowned architect, who is John Zarafa, he introduced the solution, but it will cost very expensive. So well, their suggestion will be accepted as no other option is viewed by others. The total estimate amount cost about 3 Arab 40 crore, so which is at least too much expensive. So the team decided to display a factory where these glass panels were designed and manufactured by the workers themselves. This needs 4 months periods to manufacture these aluminum glass panels. The last challenge will be the placement of telescopic spire. In the last year of construction of Burj Khalifa is almost ready to launch. Gas, electricity, and sanitation installation has been done, but still something is missing, and this is Burj Khalifa top floors. Construction is uncompleted. A solid steel pipe need to be installed at the top, having about 136 meters long and 350 tons heavy. The problem here is as there is no crane present in the world that can uplift this much weight and accessible to reach that height. So at last, the team decided to install the steel telescopic spire by keep lifting it into parts turn by turn from inside the building towards the upper position. When the parts of the spire reach the top, workers there assemble the parts and this way the steel spire gets situated in their constant position.
Assalamualaikum, my name is Muhammad Amar bin Zainuddin and I will continue this presentation on the success factor of Burj Khalifa project. To further our discussion, there are 4 success factors for Burj Khalifa project. One of the most important difficulty the design team had to address in order to make this project a reality was how to lessen and regulate the wind force on the tower. Burj Khalifa originally was located in the hot and dry middle eastern of Dubai with harsh weather such as sandstorm and strong wind. The best solution found out by the project management for this issue was a triaxial Y-shaped plan. The plan was applied in which tier of the building set back in a spiral stepping pattern up of the building. The main purpose of Burj Khalifa implementing a Y-type plan design is to boost safety and security against high winds from the coast. In regards, the design helped increase the success percentage of the project. Next, the second success factor for Burj Khalifa project is mixed reinforced concrete. Burj Khalifa tower is supported on a 3,700 mm tight, high performance reinforced concrete bus supported rough foundation. The reinforced concrete rough foundation is built with high performance self-compacting concrete SCC and is installed on a minimum 100 mm blinding slab above a 50 mm waterproofing membrane. Along the lines of safety of the occupant, wind engineering is considered to reduce the dynamic wind excitation. Furthermore, using mixed reinforced concrete as the main material for the whole structure is one of the success factors in completing Burj Khalifa Tower, resulting into a stable dynamic response. Taming the powerful wind force, it is counted as one of a success factor for Burj Khalifa project. The third success factor for Burj Khalifa project, which is 3-day cycle. The development of Burj Khalifa project, which is targeted for 160 floors and rises into the sky and to an unprecedented height that exceeds 700 meters, has developed a new technology which is called the 3-day cycle. Ultimately, with the initial plan to complete in 47 months, of course would have a very tight schedule to be achieved. This method defines a construction approach that attempts to raise the entire structure of one story every 3 days. Below is the key construction integrating in order to achieve the 3-day cycle set for the concrete works, which is ITO climbing formwork system ACS, high performance concrete, advanced concrete pumping technology, simple drop formwork head system, column or wall, which is part of ACM formwork system. This technology used to achieve the 3-day cycle were considered as one of success factors towards Burj Khalifa project. The fourth and the last of the success factor shows that management competency of Burj Khalifa project. The author have highlighted that the project manager competency is the most important aspect in achieving that set objective. Moreover, having resource management may be one of the most important issues to consider, depending on who building the construction. For the Burj Khalifa project, the general contractor are Samsung Engineering, which is Korea-based contractor, and also B6 Belgium-based contractor, and Arab Tech Dubai-based contractor. One of the huge impact from Samsung Engineering is toward communication management. Said by the Chang Gen Lee as the project manager for Samsung Corp, problem with our communication system appeared as the building reached the 30th floor. Furthermore, the walkie-talkie got less and less dependable as the tower grew, causing delay and safety concern. Ultimately, Samsung Corp devised a wireless mesh network to address this problem, allowing for clear voice connection as well as real-time video broadcast and surveillance. This wireless mesh solved a crucial communication issue, allowing construction to proceed safely and on time. For the conclusion, The development of tall building system is always linked to the newest breakthrough in material technologies, structural engineering theories, wind engineering, seismic engineering, computer technologies, and construction process, as demonstrated by Burj Dubai project. Burj Khalifa, the skyscraper drew a lot of attention from people all over the world, and it became one of the most well-known tourist attractions in the world. During the presentation, 5 main points were included as to show the overview of Burj Khalifa project. Originally, there were 7 types of technology used during construction for Burj Khalifa. The technology used were geotechnical technology, concrete pumping technology, wall and floor technology, formwork technology, external wall technology, fire protection technology, and wind engineering technology. Every type of technology will provide different functionality. For example, the purpose of using wind engineering technology was for Burj Khalifa to be able to withstand to the wind forces. To sum up everything that has been stated so far, all the smart technology used during construction for Burj Khalifa Tower plays a crucial role as contributed toward the success of the project. So that's all from me and from our group. Thank you.